Robert Smith, 34 of Gloucester Township, was killed September 8, 1992, when a scaffold near the top of the Walt Whitman Bridge collapsed. Smith plunged more than 360 feet into a Gloucester City parking lot. A second worker, Jose Medeiros of New York City, was left dangling for 45 minutes until rescuers could save him. Both men were engaged in painting the bridge. A company spokesman said both workers were wearing safety belts, but neither had his belt attached to a safety line when the accident happened. 6 months after this tragic accident took place, OSHA issued a citation alleging that the employer of the two men, with the following willful or serious safety violations: overloaded scaffolding. The scaffold was moved while the workers were on board. The scaffold was not set up and moved by a competent person. It had inadequate suspension ropes. The ropes were improperly rigged. The hoisting machine did not have a secondary emergency brake. And finally, the employees were not properly instructed in the use, inspection, and maintenance of scaffold hoisting equipment. The employer has contested these allegations, but the fact is, Robert Smith is dead. While he fell to his death from hundreds of feet in the air, many scaffold injuries and fatalities have occurred when the victim was working only a few feet above the ground. Such accidents and the injury and loss of life that often accompanies them can be prevented. In this presentation, we'll review the various categories of scaffolds and examine some of the procedures for safely using scaffolds at all elevations. Let's start with a little background information and history. Scaffolds have been in use for centuries. Michelangelo painted the frescoes on the ceiling of the Sistine Chapel while lying on a scaffold. The function of a scaffold is to provide elevated support for workers and materials. For example, while constructing, repairing, or painting a building. Scaffolds are generally designed to be used on a temporary basis. At the conclusion of the work, the scaffold is disassembled, moved to a new location, and reassembled. Every scaffold should be capable of providing a safe work platform for its users. But improperly erected, damaged, overloaded, or otherwise misused, scaffolds present a hazard and the potential for a serious accident, like the one that took the life of Robert Smith. The most widely used scaffold is the stationary upright type. Other categories are manually propelled mobile scaffolds and suspended scaffolds. We'll take a closer look at each category. Stationary scaffolds are fabricated as a framework of wood or metal supports and may be extended as the work moves higher. Manually propelled mobile scaffolds, sometimes referred to as rolling towers, are also constructed of wood or metal. Mounted on wheels or casters, these structures can be moved from place to place. Suspension scaffolds, such as the one Robert Smith and Jose Medeiros were using to paint the bridge, carry a working platform suspended on ropes or wires attached to a structural member or an outrigger beam above. The first step in the safe use of any scaffold is to have a competent person supervise all phases of erection, dismantling, or modification. Once erected, the scaffold must be carefully inspected, again by a competent person, before it is put into use. The purpose of this inspection is to ensure that the scaffold has been correctly assembled and is capable of supporting at least 4 times the intended maximum load. The upright supports and horizontal members of stationary scaffolds must be square and level. All cross-bracing and diagonal bracing must be correctly assembled and securely attached to create a strong and rigid structure on which the scaffold platform can be placed. It's critical that the footing and anchorage for stationary scaffolds be sound and capable of supporting the maximum intended load without settling or shifting. As an added safeguard against movement or tipping, stationary scaffolds should be secured to the building or structure using heavy wire or brackets. For wood scaffolds, this should be done at intervals of 25 feet, both horizontally and vertically. And for metal scaffolds, every 30 feet, horizontally, and 26 feet vertically. Platform planking must be constructed of number 1 grade lumber and secured at both ends to prevent movement, and laid side by side to prevent tools or materials from slipping through and causing an injury to those below. All planks should be free of excessive splitting, dry rot, or other defects. The scaffold platform must not extend more than 12 or less than 6 inches past the support points. If the planks are allowed to extend beyond the 12-inch maximum, there is a risk of dislocating a plank by stepping on the unsupported end. The minimum 6-inch extension is necessary to assure that the planking does not slip out of its supports under pressure. Some prefabricated scaffolding uses metal planks attached directly to the support rails. In this case, the platform need not extend beyond the support points. Guardrails and toe boards should be installed on all sides of any scaffold platform, elevated more than 10 feet, and on any scaffold that has a minimum horizontal dimension of less than 45 inches in either direction, with a work platform that is 4 feet or more above the surface on which the scaffold is standing. The top guardrail should be constructed of 2x4 lumber, or the equivalent, and positioned at a height of approximately 42 inches above the platform. Toe boards at least 4 inches high should be placed close to but not resting on the scaffold platform. To prevent the dislodging of materials stacked higher than the toe boards, a screen or wood paneling should be used to cover the area between the toe board and the guardrail. While the erection and use guidelines for a mobile scaffold are similar to those for a stationary scaffold, there are specific practices related to its rolling base. To prevent tipping, the maximum work height of a mobile scaffold must not be more than 4 times the shortest distance between any two of its casters. If for any reason this condition of use cannot be met, outrigger frames should be added to enlarge and stabilize the base. Rolling or mobile scaffolds can only be used on level surfaces, and all wheels must have a positive lock to prevent unexpected movement. As we discussed earlier, staying on board a scaffold while it is being moved can have tragic results. To prevent struck-from-above accidents, the scaffold should also be cleared of all unattached items prior to its relocation. Suspended scaffolds provide a work platform suspended by ropes or wires. They can be attached to a structural member, as in the case of the scaffold used by the bridge painters, or to a fixed outrigger on the roof of a tall building. These fixed outrigger beams must be at least 15 feet long and should not extend more than 6 feet beyond the bearing point. Because suspension scaffolds can swing and move in the wind, it's essential that the platform be secured at both ends by horizontal lines attached to the building or structure. The wires or synthetic or fiber ropes used to support a suspended scaffold must be rated capable of supporting at least 6 times the maximum intended load. This includes the weight of the scaffold itself, as well as that of the workers, tools, and materials on board. Most suspended scaffolds are raised and lowered by a mechanical hoist. The hoist should be checked regularly to make certain it is operating safely and has a secondary emergency brake that is in good working order. To ensure true winding, at least 3 turns of rope should be left on the hoisting drum when the scaffold is at its lowest position. This also reduces the force exerted on the rope at the point where it connects to the drum, and lessens the possibility of the rope slipping from the drum or breaking. It's vitally important that everyone who is required to work on any type of scaffold with a platform more than 6 feet above the surface must wear a safety harness and lanyard. The lanyard must be fastened to either a structural member or a securely rigged lifeline that will safely support the worker if he or the scaffold itself should fall. For obvious reasons, the lanyard must never be attached directly to the scaffold, and if it's not attached to anything, it certainly won't help. Welding, burning, riveting, or open flame work should never be performed on a scaffold suspended by fiber or synthetic ropes. Treated or protected fiber or synthetic ropes should always be used if the work will involve the use of corrosive substances or chemicals. As is true of other types of scaffolds, suspended scaffolds should not be moved until all unattached materials and tools have been cleared from the platform and all workers have dismounted. Now let's briefly review some of the important points of safe scaffold use. Regular inspection and maintenance is a key element of safe scaffold use. Scaffolds of every type should be inspected by a competent person after any one of the following events: initial installation, any alteration or modification, a severe wind, rain, ice, or snowstorm. If a scaffold is identified as damaged or flawed in any way, it should be taken out of service until all necessary repairs can be made. All stationary, upright, or mobile scaffold components must be capable of supporting at least 4 times the maximum intended load. Every scaffold should be erected on a level and firm base under the supervision of a competent person and then carefully inspected before being put into use. The wire or rope holding up a suspension scaffold must be capable of supporting 6 times the maximum intended load. When working on a scaffold that is elevated at 6 feet or more, a fall protection system, such as a safety harness and lanyard, must be used. The lanyard must be attached to the structure itself or a securely rigged lifeline. Finally, before a scaffold is used as a work platform, it must be clear of tools, materials, debris, and ice, snow, or other slipping or tripping hazards. Scaffolds are indispensable tools for a wide range of construction, industrial, and commercial applications. But it is vital that every scaffold be designed, erected, used, and maintained with an understanding of its unique characteristics and a knowledge of the potential hazards associated with its use. Your ability to recognize these potential problems, coupled with a commitment to follow recommended safe work practices, can significantly reduce the possibility of your becoming the victim of a scaffold fall.